All right, we're recording and we're tired.
Ooh,
It's a Tuesday.
we're
Tuesday's a
already
good day.
tired. Already tired on a Tuesday.
Mm-hmm. Hope everyone out there is doing all right. Taking it easy. Let's learn some more about logarithms. So we have 4 properties. Let's throw our names on here.
Oh, Mr. Kirk, are you sharing your screen?
Oh, I'm not.
That's
Let's
how
learn
tired
more.
we are.
Yeah, let's learn more about logarithms. What's the day? I just said it was Tuesday.
We just said it was Tuesday.
Man, hopefully this video turns out all right. And then the sum period.
Point. It's exclamation point period.
True. Let me get rid of it's all
right. There's interrobang. I wonder if the kids know about interrobang.
What's that? I don't know.
It's a question mark exclamation point put together.
Oh, what is it used for?
Anytime you would do question mark and exclamation point next to each other, you just put it together into one.
Is that a legitimate punctuation?
I don't know.
The question is it on Wikipedia?
I think so.
Oh, okay. Anyways, let's proceed. So we got some properties that we did last time. The product property, meaning we can split up the product within one log into 2 logs, or vice versa. Take 2 logs, turn it into 1. I feel like we used it in reverse more often when we were solving last time.
It's true. I think
with the quotient rule. Yeah.
I think that knowing which direction you want to go and which one is useful is that's kind of the hard part too.
Power property, bring that exponent down. You know, I was watching WWE the other day, like wrestling. That is an entertaining TV experience, especially during COVID, because there's TVs of fans everywhere. It was pretty wild.
Wait, so they have all the fans on TVs?
Yeah.
Inside the stadium, but not. Wow. That's pretty cool.
I'll go 363 days without watching WWE, and then there'll be like 2 days where I just watch it a lot. I watched it for a couple hours the other night, and then the next night I watched it a little bit more. But then I've passed my my wrestling, my professional wrestling. Anyways, then we have the change of base formula, which hint is going to be a very powerful rule for proving a bunch of other stuff. Here's what we're going to do today, guys. We're going to solve that problem that we didn't do last time. I've changed the names to make it DuckTales themed. That's just required. Although we had a discussion before we started that Daisy Duck might not be in the television program.
Or she might not be in the new one, because the 2017 one, that's the only one I've seen.
Then we're going to do some more properties. And a hint, that change of base formula hopefully will be pretty useful. We got the direct proportionality property. All right, there is some number that when I multiply a log, I can get a different log. We have the reciprocal property, which actually some people in my class, Mrs. Contreras, derived this on their own.
Whoa.
In solving, there was a problem in the last problem set, log base 8 of 4. And they looked at it log base 4 of 8 instead and reciprocated their final answer. It was right. There you go. We're going to talk about why that's true. We got the product of 2 logs. So log base A of B, log base B of C. You can kind of get rid of the B's. Log with power for base. Oh, so if the base has a power, we can pull that down like the power rule, but it comes out as the reciprocal. All right. If both the base and the argument have the same power, chop, chop.
Chop, chop.
Get rid of them. And then it looks like there's our 10th property is going to be we can reciprocate both the base and the argument. Reciprocate. That would be my wrestling name.
And now you said it so many times that it really has to be.
Yeah, I know.
So whenever you quit teaching to go be a professional wrestler.
Maybe we'll have let's have a Dwayne The Rock Johnson theme where we both dress up like Dwayne The Rock Johnson.
What does that mean?
He has this style, this late 90s style. Anyways, all right, this is what we're doing today. Let's try to solve this problem that we talked about last time. I think it's really worth doing in a video. Mrs. Contreras, will you do us the honors and read us this story in your most thespian voice?
Thespian. Oh, I was going to try to do Donald Duck, but
Oh,
yeah,
that'd be
let's do
cool.
Thespian
Yeah, let's do
instead.
this. Yeah.
No. Donald Duck deposited $2,000 into an account that pays 4,000 annual interest compounded quarterly. At another bank, Daisy Duck deposited $1,500 into an account that pays 6% annual interest compounded continuously. How long will it take before Daisy Duck has more money in her account than Donald Duck has in his account?
I think I put Donald Duck as the person that was putting it in the worst account because I just feel like Donald Duck would be the person or the duck to put their money in the worst account.
And then he would be like really upset about it too.
There we go. All right, that's enough of that. Hopefully that it drowned out like it does when it beatbox. When I beatbox. Anyways, so we need to figure out when these accounts. Oh, when Daisy Duck's account overtakes Donald Duck's account. So we need formulas. What is the compound interest formula?
Well, we have the principal amount.
Okay.
Multiplied by 1 plus the rate, the interest rate over the number of times you're compounding per year, raised to that number of times you're compounding per year times the amount of years that you're working with.
Boom. Yes, if you're getting like, if you're in the case of Donald Duck, you're getting it quarterly. You're getting 4% at the end of the year, and the bank's dividing that up into 1%, 1%, 1%, 1%. And you're doing that 4 times. So you need to multiply your 1% 4 times. So there's a 0.04 there. There's going to be a 4 down there, and there's going to be a 4 up there. See, that's the compound. What about the continuously compounded interest when n is infinity?
It's the one that you hate, but I really like it. It's PERT. But they're different principal amounts, right? So maybe we should label them. Oh, they have alliterative names and they're both ducks. Okay, 1 and 2. Yeah, that works.
And we can just like, organization is key. Let's just like write Donald Duck here. And we'll write Daisy here.
We should also probably label the rates, rate 1 and rate 2, because they have different interest rates.
They are, yeah, rate 1, rate 2. Cool, so let's fill this thing out, and then I think it's going to be an equation that we need to generate. So I'll go ahead and get the first one, just because I've already said a lot of those things. Here are the amount Donald is investing in the bank, $2,000. The rate is 0.04, not 4, 0.04. And then that's getting divided up into 4 increments because we're getting it quarterly. And then so we're going to get 1% in like March, and then we're going to get 1% in like January, then April, and then July, and then September or something like that. So we're going to get it 4 times, and that's in 1 year. If it happens for more than 1 year, we'll have it 8 times, 3 years, 12 times, etc. So there's my formula.
Cool. I like it. It's a good formula.
It's a good formula. How about Daisy's?
Well, she has $1,500 as her principal amount. Since we're compounding continuously, we still use E. We don't have to do anything else with E. And the interest rate is 0.06 times 10.
Boom. The rate finds its way into the exponent of the continuous formula because of that beautiful number E. Okay. There is R embedded in there, and N. When N goes to infinity, the number goes to E. All right, so I think we need to set these things equal and solve.
That sounds good.
Because if we set them equal, then we'll know at what point they are the same. And then any moment after that, Daisy Duck is going to have more.
And we know that they're only going to intersect 1 time because we have exponential functions, and those are strictly increasing. I think we talked about monotonicity before. They're monotonically increasing. So they're going up and not going down. So once these 2 functions are equal, then they're never going to cross again. Yeah. Nicely sketched, Mr. Kirk.
Excellent. And our final answer is going to be like t is greater than something.
Mm-hmm.
Once we find t, any moment after that, if we are thinking about money being compounded instantaneously. All right, so let's set these things equal to each other. 2,000. 1 plus, do you mind if I write 1.01?
Oh, totally. That's totally cool.
That's just that to the 4t.
Mm-hmm.
And then is equal to 1500 e to the 0.06 t. Cool. We need to solve this thing.
We should get rid of those zeros. There's a lot of zeros.
Chop, 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 chop.
Is that for
20.
the log unit? We're just chopping. We're not doing any.
We'll go back to Star Wars when we get to Drake.
All right.
Okay.
Hmm.
I have a proposal. Can we divide both sides by 15 so that e is our lone base?
So then when we're taking the natural log, that goes away. That sounds brilliant.
So 20 over 15, that is 4 over 3, right?
4 over 3.
1.01 to the 4t is equal to e to the 0.06t.
Natural log both sides.
I'm running out of room.
Oh, no.
Natural log both sides. ln 4/3 times 1.01 to the 4t is equal to just 0.06, right?
T. Yeah.
Yeah, t. All right, so we like natural log both sides. Let me like write that. ln of this, ln of this. Oh. I feel like we're getting more complicated.
No, I don't think so, because we have those properties that we learned about last time, where we can handle having a natural log of things that are being multiplied and raised to powers and divided, because we can just break those up into different natural logs.
We cannot bring that 4t down though, right?
Not immediately.
Not immediately. We have to break up 4/3 and 1.01 to the 4t.
I think so.
Because the 4/3 is not being raised to the 4t. So we have ln 4/3. Make sure I'm using my log rules correctly. ln 1.01 to the 4t. Let me actually put the 4t in the parentheses just so I'm not confusing anyone. All right.
Well, now the 4t, that can come out.
4/3 plus natural log. Well, let me bring in the 4t down. Let me actually do that.
To the front, because you like doing
t ln 1.01. Boom. And we actually kind of have like a number sandwich right here, right? 4t ln 1.01. Because 4 is a number. The natural log of 1.01 is a number. And t is like in between it. So I'm going to like...
number sandwich.
Yeah.
So now we just combine like terms, right?
I think so. So how do you want to do this?
Well, I think that the t's should go together on the same side.
So maybe leave the 4/3 on the left-hand side of the equation. And so 0.06 t minus 4 ln 1.01 times t.
Yes.
I wish it wasn't so small. I wish I had, prepared my space a little bit better.
Well, you can like select it and move it over.
Yeah. Let me actually do that. Actually, I'm going to rewrite it. I'll do it fast, I promise. Because I think my handwriting got a little bit sloppy there at the end as well. So we have natural log of 4/3 is equal to 0.06 t minus 4 times the natural log of 1.01 times t.
Beautiful. Because now there's a greatest common factor. Whoa, so much zoom.
And I also really, I can see it a little bit better now. Yeah, greatest common factor. What is that GCF?
It's the t.
It's T. So we have 0.06 times T minus 4 ln 1.01 times T. Cool. And I think we're done, right? Well, not done, but
got to divide by that number that's inside the parentheses.
T is equal to 4/3 divided by 0.06 minus 4 ln 1.01. We need a calculator.
I am calculating.
You are? Cool. Then I'll put my TI away. The answer is...
Wow, I'm not that fast with the calculator.
I know. I was so, two ducks walk into a bar. I don't have an interest to it. And they say, ouch. I get it. They walked into a bar. I have my Festivus poll right here.
Okay. I have a number for you. It is.
You have a number, cool.
So I'm just going to slap what I put into Desmos into our doc.
Are you like snipping and pasting?
Big. It's kind of big though.
You can. I'm gonna pull with it.
Boom. Boom.
I'm waiting.
Boom.
Is Tom having issues?
Maybe.
Oh, there it is.
Oh, nice.
But I need you to move it over.
It's moving. It's just thinking about it. But it's like 14.2 for stuff.
And that's what was our increment of time? Years?
How long will it take?
I believe we're working in years. T is just because this is an annual interest.
Mm-hmm.
So 14 years, we will overtake that $500 that was not put in. 14 years. So we're gonna say T is greater than 14.24 years. And if we're working discretely, one might say the first year is 15 years. Both of these are valid. It depends on how the bank is dealing out its money, whether it's
could you say like 14 years and what is it? What's a quarter?
3 months.
3 months.
Yeah, if it's doing it, I guess if it's being done quarterly, then 3 months is a quarter. So if it's dealing out its money every quarter. But Daisy Duck, I believe, is getting that that compounded continuously. All right. That is an obnoxious amount of algebra, but it's basically a linear equation at the end of the day with some nasty looking numbers. And if it makes you feel better, you could always save those numbers in your calculator, and then instead of writing ln 4/3, write whatever ln 4/3 is. But I think the goal is ultimately to be able to work with natural logs in their natural habitat.
Yeah.
Okay. Let's prove some more log properties and then enjoy the rest of our Tuesday.
Okay.
Cool. So we've already proven 4 properties of logarithms that were listed above. Now we're going to prove the following properties for logarithms.
And you were saying that we should use the change of base formula. You said that like 5 or 6 times. So I feel like we should use the change of base formula.
I think we should. All right, so let's do it. The direct proportionality property. This one says that there is some number C that takes log base B of x to log base A of x. I've prepared something real quick. Let me jump over to Desmos real quick.
Nice.
And I've graphed 2 arbitrary log graphs. I have log base 11 of x and log base 3 of x. And I've multiplied log base 3 of x by a. And I have a slider here for a. So as I move a, it changes the log.
Hey, it looks like there is a point where your blue and your red graphs are pretty much the same.
And I'm working, I believe, with an increment of, let's get my step to be like 0.01.
Ooh.
And is that what I want? No, I want 0.001. I don't think it's like really granting me that power.
Because you need to change the bounds on your A. So you say it's from like, I don't know, 0 to
2.
Yeah.
All right. All right.
There
Okay.
you go.
Ooh. So some number, it looks like it's a little bit less than 0.5. It's more than point. Well, that's pretty darn
Hey,
good.
that's pretty dang good. Oh,
So it's less than 0.46 and greater than 0.45. There is a number that exists between those two numbers that takes my log base 3 to my log base 11. What is that number? That's what we want to show here. Change of base time. What do you think?
we should change the base.
So we have log
Probably
base.
Yeah, the left side seems easier to work with. Log
Mhm.
base A of x, so that would be log of x over log of A. What base should we use? Should we use base 10 or should we use base something else?
I think. Hey, let's just go with the common base 10, and see if we can turn this into a log base b of x. What do I need in order to get that base b?
We need to divide by log of B.
And so if I divide by log of b, then I have my log of x and I have my log of b, and those will combine into the log base b of x. That's the change of base in reverse. But I have to compensate that log of b with a log of b in the numerator.
Mm-hmm.
Can you help me make this neat? What do you think I should do here?
Probably just swap around what our denominators are because of the commutative property of multiplication.
Boom. So log. Let's we're gonna just do some switchy.
Oh, nice. He did an arrow. Bam.
Nice.
So now on the left, what we have is log base B of x. And on the right, we have a number. And the number is log base base A of B.
Wait, so log base a of b. Let's go back to our Desmos. Log base a of b. So if I want to turn log base 3 into log base 11, then I believe I'm going to have log base 3 of 11.
But that's like way too big, right? That's 2 point something something.
Maybe it's log base 11 of 3.
Oh, that looks like right in the window of what we were looking for.
0.45 to 0.46. And right, if I take log base 11 of 3, then I'm going to be left with a log base 11. I think I need to introduce that base of 11 to get to my log base 11.
That makes sense.
If I then take this and I just multiply by log base 3, not log base x.
Oh, getting crazy.
X. Close that parenthesis. Why doesn't it like my
Maybe it wants parentheses. Yeah.
Yeah. Let me get rid of this A1, and that looks like it did it.
That
Can you see that it's toggling?
Can you switch it to projector mode?
Yeah. This?
No, in the top right, in the gear, or in the wrench.
The wrench.
Projector mode. So the very top. Click.
Ooh.
Oh yeah, that's more
Look
clear.
at that. Legit. All right, so not only do we know that there is a number that takes me from any log to any other log, but that log is log base A of B. That number is log base A of B. This is the direct proportionality property of logarithms. Legit.
Cool.
All right. Reciprocal property.
Hmm.
What are you feeling?
Change your base.
Change of
Feels
base.
like a change of base.
Change of base. All right, so let's see. Log base A of B.
So that's log of B over log of A.
Okay. Y'all know what that
mean,
means?
reciprocate.
It's time to reciprocate 1 over log A over log B, right? That's
Because
legit.
you reciprocated and you reciprocated. So reciprocating the reciprocator is just the
It's a
original.
double reciprocator. That's my signature.
Reciprocate.
That's my signature move. Watch out.
The double reciprocate. Then
The
you just
double.
you put your opponent back on their feet.
Yeah, but it's so disorienting that they fall over and lose. All right, so I believe we're like milliseconds away.
Oh, well, the denominator, the denominator of what got reciprocated is log of a base b, log base b of a.
Of A, yeah. And that's what we wanted to show, right?
Yeah.
Log base A of B is equal to just rewriting the beginning and the end. I started to laugh while you were talking because I decided what your wrestling name's going to be.
Oh, no.
It's the denominator. Oh, boy. All right. That is the reciprocal property of logarithms. You can switch the base and the argument, but by doing that, you must reciprocate. All right.
This is too silly.
I know. It's a little bit too silly.
But now I'm just thinking of like all the wrestling moves that the denominator would do. And it's just like going for your feet. You just like pull your feet out from under you.
Yeah, the numerator is like the sidekick.
Oh, just like a head takedown. No, numerator.
All right, so a lot of these properties are interesting and useful in solving logarithms and their equations. So I encourage you guys to pause for a second, go and download the PDF of this, or just like look at what's on the screen, pause it, and try to prove it yourself, because we just changed in basis. Log base A of B times log base B of C is equal to log base A of C. We're just changing bases. So try to prove all these yourself. I'm more than confident that you guys can do it. Let's do some change in base.
Right. So log of B over log of A times log of C over log of B. And then we just take those denominators and we switch them around because of the commutative property of multiplication. That's 1.
Chop, chop.
Chop, chop.
Oh, I wrote B by accident. That's an A. That's an A. Chop, chop. Gotta throw some Star Wars in there just for the sake of
old times.
Star Wars in it, yeah. Old times. I think we're left with log base 10 of C, log base A, log base 10 of A. We could use any base we wanted to do these, I think.
We're just efficient and don't write extraneous things.
If we wanted to be extra efficient, we could do this entire page with the natural logarithm, one less letter.
Yeah. Although for the next one, we probably shouldn't because there's an N in that.
Log base A of C, which was the proof that we wanted to show. Chop, chop. Right. Our problem set that we're going to be sharing with you guys for next class utilizes these 6 properties that we're doing right now, 5 through 10, all over the place, and it makes life easy. But at the end of the day, if you forget these rules, they're all just change a base. Just change your bases. All right, so you're suggesting in property 8, the log with powers for base. Basically, the reciprocator version of the power rule, that we should not use natural logs. Okay.
Just because there's an N, like it's just.
I'm in spite of you. I'm gonna use a natural log. I'm gonna change log base b of to the n of x into the natural log of x over the natural log of b to the n.
That's fair.
All right.
Yeah, you can do that. Not going to be upset that you're not going with my idea. It's okay. It's part of group dynamics. You choose your battles. And just because you have a different idea from me doesn't mean that either of us is wrong.
All right, what should I do here?
So I think that we have the power, right? Natural log of b to the n. So we can pull that out. And then isn't that lovely? Because we can just split that up a little bit if we want to make it even more clear what we're doing. We have 1 over n times, natural log of x over natural log of b, and that's a change of base that we can change into the log base b of x.
There we go.
And that's what we wanted.
These are all, and I feel like the power rule, was that? No, that wasn't just change of base. The power rule, when we proved the original power rule, we used the inverse property of logarithms and exponentials, right?
That was, yes. Yeah, because we did a to the natural log of base a, or a to the log base a of something.
So not everything is change of base, but change of base is pretty sweet, and just the inverse property of these functions is fundamental. All right, we got 2 more properties, and then in class next time, guys, you will use these properties. A tough assignment's coming, but I think it's gonna be what's the word? Rewarding, satisfying. All right, property number 9.
Yeah, they're all like little puzzles.
Mm-hmm. Base and argument are like powers. We can get rid of the powers. Okay. What do you want to do?
Well, I just want to like first just look at it and just convince myself that it's okay, that we're just kind of like taking the n power away. Just like, oh man, that feels dangerous, but okay, let's just try the math and see if it actually works. So change of base.
Let's do it. So log.
Oh, you don't want to do a natural log anymore? This is prime opportunity where there's extra n's.
So many n's.
So many. But now we can just pull those down.
Mm-hmm.
And then n over n, chop chop.
It's just a fancy version of 1. Chop. Log x over log b. I'm going to fix that x because it's not that nice.
But I could follow what you were doing because you were talking through what you were saying, which is also helpful. Yeah. And that change of base back up to log base b of x.
Which is our initial, that's what we wanted to prove.
Yes.
Change of base for the win. I'm gonna go ahead and say it. Change of base is my favorite of the properties.
You're not supposed to have favorites, Mr. Kirk. You're not supposed to. Don't let the other properties hear you.
Psst. Change of base is my favorite property. Do you think they heard me?
Probably not. They don't have ears.
All right, we got one last one. Turns out you can reciprocate. So like if I have log base 0.1 of, I don't know, 9, that's the same as the log of, what's the reciprocal of 0.1?
10.
10. And the reciprocal of 9 is 1/9?
Yeah.
Those two things are equal.
Whoa.
Let me actually write this as 1/10. But you must reciprocate both. I have a strange feeling that this is change of base.
Well, yes, but what if in the other one from property 9, you said n equals -1?
Is this just a special case of property 9?
Is it? Is it?
We're trying so hard. All right. Sorry to those that are cringing like so hard that your like face is like imploding.
But journal about it, you know? It's good. It's good to have feelings.
So you're trying to write 1 over b as b to the -1?
Yes.
And 1 over x as x to the -1?
Yes.
And then just like by prop 9?
Prop 9.
Prop 9. Be the x?
Yeah, seems like it. But, I mean, change of base would also work.
I feel like if we did change a base, though, we would end up using the power rule regardless.
True.
Yeah.
True.
All right.
Cool.
There you go. There you have it. We let's recap real quick, and then we'll get out of here. We got 4 properties, of which my favorite property. We solved the problem that we didn't do last time. It got nasty. But then we finished up the lesson with some nice little proofs.
Yeah.
Vroom. Were you waiting for the car to go by?
Yeah. You should scroll down to the bottom of that page.
You were really... You were not waiting for the car to go by. You were trapping me. Yeah, and you thought I was going to continue to stroll, but I didn't.
You didn't, and I was so sad.
Foiled again. All right, and what else did we decide? We
wrestling names.
We had wrestling names. I am the reciprocator, and you are the
denominator.
We'll say that again because I don't think I highlighted you.
Oh, denominator.
You gotta like, awesome.
Was that from?
Yu-Gi-Oh? Yeah. Oh yeah. Mm-hmm. All right, so Yu-Gi-Oh fans out there, that one's for you.
I've actually never seen Yu-Gi-Oh.
I don't think there are really any Yu-Gi-Oh fans anymore. Unless like there are fans of the manga, but I can't remember the last time Yu-Gi-Oh was like in pop culture. I don't know. Let me know. Write about it in your journal. Any words of wisdom for the end of this vid?
Sometimes it's okay to just like be tired and keep on working. Within reason.
Sometimes it's okay to be tired, but to keep on working.
Other times it's okay to take the L and just go to sleep.
Yeah. I was going to say that. I was like, yeah, sometimes you just got to like throw in the towel. Like you would do when we're wrestling. Let me see if I have any Yoda quotes. Any Star Wars. Oh, here's a Blade Runner one. Here we go. This is what I'll end the video with. The light that burns twice as bright burns half as long. And you have burned so very, very brightly, Roy. Let's get out of here.
Okay.
I think this is a symptom of being tired.
That's okay.
Don't burn too bright.